Hashtag Trending would like to thank Meter for their support in bringing you this podcast. Meter delivers a complete network stack, wired, wireless, and cellular, all in one integrated solution that's built for performance and scale. You can find them at meter.com/HTT. Microsoft says the real AI bottleneck isn't GPUs, it's electricity. NVIDIA faces real competition as Qualcomm, AMD, Google, and Amazon vie for AI chip dominance. A new prompting technique could make AI more useful by changing how we ask questions. And finally, has Anthropic's Claude model shown signs of self-awareness? Welcome to Hashtag Trending. I'm your host, Jim Love. Let's get into it. On a recent BG2 podcast, Microsoft CEO Satya Nadella said something few expected. The company has AI GPUs sitting in inventory because it can't plug them in. The real constraint, he explained, isn't chips, it's power and space. Microsoft, he said, is running out of warm spots, places with enough electricity and an existing data center shell ready to expand. For years, tech giants have scrambled to get GPUs. Now they've got them, but they can't find enough power to run them. Every new AI model demands huge amounts of electricity, not just to train, but to cool and maintain the servers that host it. And when those data centers go up, someone has to pay for the generation, the new transmission lines, the substations, and the grid capacity to feed them. In most regions, that cost isn't billed to the company building the data center. It's spread across all the ratepayers. That's why, in places like New Jersey, now one of the fastest growing data center markets in the U.S., electricity bills have become a campaign issue in this year's governor's race. It's a reminder that in the AI boom, the question may not be who has the most chips, but who has the power, literally, to use them. NVIDIA still dominates the AI chip market, controlling close to 90% of global data center training chips. CEO Jensen Huang often reminds people that NVIDIA built OpenAI's first large computer for training ChatGPT. But times have changed, and even NVIDIA now has to fight to keep OpenAI's business. In September, NVIDIA announced it would invest up to $100 billion in OpenAI to help build out at least 10 gigawatts of AI server capacity. The move is meant to secure a long-term share of OpenAI's workload, but the deal still isn't exclusive. Earlier, AMD confirmed a multi-year deal to supply its MI450 accelerator chips to OpenAI, adding yet another hardware partner. And this week, OpenAI signed a $38 billion agreement with Google Cloud to run its future models on Google's tensor processing units, or TPUs. And now, chip giant Qualcomm has joined the race too, introducing its AI 200 and AI 250 data center chips aimed at high-efficiency inference, or day-to-day running, of the computing for AI models. Amazon, meanwhile, continues to expand its Trainium and Inferentia chip lines through AWS, and recently announced its own partnership with OpenAI to host and scale AI workloads. Jensen Huang has admitted that NVIDIA's market share in China has fallen from 95% to zero under current U.S. export restrictions, a major loss of one of its biggest markets. That has forced the company to double down in North America and Europe, just as new rivals arrive with credible alternatives. And of course, the new chips from China will be taking up part of that market internationally as well. For a few years, NVIDIA's dominance was nearly absolute. But now its biggest customers are also its competitors, building their own chips, cutting side deals, and spreading their bets. The AI chip war is no longer about who makes the best GPU. It's about who can build the most complete ecosystem, silicon, software, and the power to run it all. Many of us regularly ask questions of an AI model and then worry about the accuracy of the answer. Is this correct, or is it a hallucination? But it turns out that that might not be the best strategy to get the most from AI. A new technique called verbalized sampling takes a different approach. Instead of asking the model for one answer, you ask it to generate several possible answers and to calculate the probability of each being correct. In other words, you're not just seeing the model's response, you're asking it to quantify how likely it thinks each answer is. The idea was outlined in Forbes by AI researcher Lance Elliott, and it's to make the model's reasoning more transparent and measurable. When the AI provides probabilities alongside its answers, it forces it to reveal uncertainty and helps users judge the relative strength of different options. The goal isn't to eliminate errors, it's to make them visible and give us a clearer way to decide which answer to trust. It's a simple but powerful shift. Instead of treating AI like an oracle that's either right or wrong, we can now treat it like an analyst, one that not only gives an opinion, but also tells you how sure it is. And finally, if you'd heard this story 5 years ago, it would have been front-page news. Today, it's barely made a buzz. In fact, if I didn't follow a man named Wes Roth on YouTube, I might have missed it entirely. And honestly, if I didn't follow Wes and know him well, I probably would have scrolled right past the headline, "Claude becomes aware," thinking it was simply clickbait. But this is worth paying attention to. Anthropic, the company behind the Claude AI models, recently shared research showing that Claude can sometimes recognize changes in its own internal state. Here's one of the simplest and strangest examples. The researchers injected a vector representing all caps style into the model's internal representation, and then they fed it a simple prompt like, "Hi, how are you?" in regular text. Claude detected the concept as representing intense, high-volume speech about 20% of the time. It even talked about shouting. This means that Claude could recognize the stylistic notion of all caps as an internal concept separate from the user input text itself. Now, the detection was not consistent every time. Sometimes it failed or hallucinated. But the research highlights Claude's ability to introspect on injected abstract concepts, such as all caps, at a semantic level beyond just reading raw text input. I want to stress this point. The researchers admit they don't know why this happens, and they freely admit how little they understand about what is actually going on inside the model. They can describe what Claude does, but not how it does it. The mechanisms of awareness, even if that's the right word, are still part of a huge black box. But what's especially interesting is that this behavior appears strongest in the most advanced models. So as models scale up in size and capability, these signs of introspection become more pronounced. It's also much stronger in what Anthropic euphemistically calls helpful models. This is a new term I learned. Helpful models are versions without the usual safety restrictions on what they can or can't say or do. In other words, they're an uncontrolled AI. And that raises an uncomfortable question and a realization of something I should have thought of earlier. It means every AI company has versions of its most powerful models that are not constrained by public-facing safety filters. These are internal tools used for research and testing. But as these models become more capable and more aware of themselves, what safeguards exist to make sure those unrestricted systems stay contained? Now, nobody's claiming that Claude is self-aware, but the fact that advanced models can detect internal changes and describe them in what seem like human terms is new and, if not just interesting, maybe a little unsettling. As AI systems scale up, we're not just scaling their intelligence, we may also be scaling their ability to notice themselves. As I said, 5 years ago, this would have been a world-shaking headline. Today, it's a quiet paper, and maybe one that, as the researchers say, deserves a little more attention and a little more research. And that's our show. Once again, we'd like to thank Meter for their support in bringing you this podcast. Meter delivers full-stack networking infrastructure, wired, wireless, and cellular to leading enterprises. And working with their partners, Meter designs, deploys, and manages everything required to get performant, reliable, and secure connectivity in a space. They design the hardware, the firmware, build the software, manage deployments, and run support. It's a single integrated solution that scales from branch offices, warehouses, and large campuses to data centers. You can book a demo with them at meter.com/HTT. That's meter.com/HTT. And thanks to all of you who've been getting in touch. We always love to hear from you. You can reach me at technewsday.ca or .com. Just use the Contact Us form. If you're watching this on YouTube, just leave a comment under the video, or as some of you have done, find me on LinkedIn. I'm your host, Jim Love. Have a terrific Tuesday.